Matthew is operating his remote-controlled car. Let's go. Oh, it's just going back and forth along a straight track. Okay, bit less exciting. Anyway, let's make it even more exciting by doing some calculus. So we're given that the distance from a point P on the track is modeled by S of t equals 6t minus t squared. So basically, as time goes on, it goes away from point P and then comes back towards it. Right? How do I know it comes back towards? Well, the minus t squared, so that term is growing more quickly, so it'll eventually come back. So that's the context. Question 1, find the initial speed of the car. So a reminder to relate displacement, speed and acceleration, or displacement, velocity and acceleration. Velocity is the rate of change of distance, and acceleration is the rate of change of speed. So we are given the displacement, right, distance, s meters, and we are asked to find initial speed. So we're going to need to work out the speed equation. So to find the speed equation, we differentiate the distance equation. So the derivative of 6t becomes 6, right, or 6t to the power of 0. T to the power of 0 is 1. And the derivative of minus t squared is minus 2t. Again, taking the power, multiplying it out the front, so minus 2, and then subtracting 1 from the power to give t to the power of 1. So we have our speed equation, and we're asked to find the initial speed of the car. So the word initial means when time is 0, right? When we start the stopwatch, when time is 0. So v of 0, or you might see sometimes v subscript 0, they both mean initial speed. When time is 0, we get 6 minus 0, which gives us 6. Do we know what's meters per second? Oh yeah, s meters and times in seconds, yeah. So initially, the speed of the car is 6 meters per second. It's pretty fast. And getting that correct would be achieved, because we calculated the derivative, and then we used it to find some meaningful information, in this case, the initial speed. Alright, part 2, how long, so time, how long after leaving P does the car change direction? Okay, so it's coming along, it's moving, and then at some time, it goes back the other way. Changes direction. Alright. Few ways to consider this. I think the easiest way to visualize is actually to graph the distance function. So let's just do that first. So 6x minus minus x squared. Draw. Awesome. So at time 0, it starts at the origin. After some time, it goes a certain distance away. It goes 3 meters away. 9 meters away, and that's at 3 seconds. And then right after that, draw trace. Right after that, at like 3.2 seconds, right? See, it's starting to come back down. The y value, or the distance, is decreasing. So just looking at this, I know that at 3 seconds, it is as far away as it will be before it changes direction and comes back. Cool. Now, this is a calculus paper, so we do need to show that using calculus. So, we know that point right when it turns around, so like as the car changes direction, its speed would be 0. Right, so the analogy is, if you throw a ball up in the air, it's accelerating down due to gravity the whole time. However, it'll keep going up until a point where its speed is 0, like it's just momentarily frozen before it comes back down. So likewise here, except this time it's on a flat surface, as it changes direction, its speed would equal 0. So we know the speed equation is 6 minus 2t, so we will equate that to 0. So in doing so, adding 2t to both sides, dividing both sides by 2, the time would be 3 seconds when the car is changing direction, when it's momentarily still. Now, that would be enough for a cheat. However, for merit in this question, we do need to justify it. So a few ways to do that. We could say speed at like 2.9 seconds and work out the speed, whereas speed just after, so at 3.1 seconds, and we will see that it goes from a positive to a negative speed, which tells us it's changing direction. Alright, which means the car is returning back to the start. And to actually show that, all as we'd need to do is substitute in to the speed equation. So 6 minus 2 times 2.9 would be, what is that, 0.2? Yep, so right before 3 seconds it has a positive speed, whereas right after 3 seconds it has a negative speed. Therefore, it must change direction at 3 seconds. Cool. Alternatively, you could sketch the graph that we just did together before to show that it's a maximum point and that to the right it is returning back to the start. Alright, part 3. So part 3 is asking how fast is the car moving when it reaches P for the second time. So, to find the time at which it reaches P for the second time, so remember P is the initial distance of 0. So using our distance equation, S of t equals 6t minus t squared, we are interested to find when it is back to the start, right? When distance is 0. And so substituting in 0 for distance, we get a quadratic equation, which we could factorize. Yep, so pulling out the common factor of t. And for us to solve this, either t must equal 0, or 6 minus t must equal 0. So, t equals 0, or 6 minus t equals 0, so t would equal 6 seconds. So let's have a think, what does that mean? So, when time is 0, it is at point P, right? That makes sense, that's where it starts from. But also, after 6 seconds, it's gone away from point P and come back to point P. So at 6 seconds, it has returned to point P. Now the question is asking, how fast is the car moving? So to find the speed, we need the speed equation, which we have, right? V of t. V of t equals 6 minus 2t. So speed at 6 seconds, which is when it returns to point P, is the speed at 6 seconds is 6 minus 2 times 6, 6 minus 12, so minus 12 meters per second squared. Excuse me, minus 6 meters per second. So what does that tell us? It tells us when it reaches P for the second time, instead of moving at 6 meters per second to the right, it has gone and it's come back, and it is now moving at 6 meters per second to the left. So 6 meters per second in the other direction. Not necessarily right or left, because I don't think they told us it was moving right. No, yeah. So 6 meters per second in the other direction than how it started. Cool, so for this question, if we got time equals 6 seconds, by firstly acknowledging that it'll reach P when the distance is 0, and then we solved for t to get 0 in 6 seconds, right, that would be achieved. We then use that time in our speed equation to find the final velocity, and we link that to being in the other direction. That would be the merit component. Alright, see ya.